Good morning. This is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. I'm going to discuss about the topic magnetic field intensity. So before starting with the presentation, let's recall about the electric field intensity. Electric field intensity is due to the various charge distribution, and the device that is used for storing this energy in electric field is a capacitor. First thing is that how to perceive and quantify this invisible force. So the magnetic field is a guiding compasses, and through experimental observation we can infer its presence. And the major source of this magnetic field is a current. Current carrying conductor produces a magnetic field. So the major source of this magnetic field is a current. Then how to quantify the strength of the magnetic field? So the strength of the magnetic field is determined by the magnetic field intensity. This only describes a magnetic field that is produced by the external current, and it is independent of the medium. The unit for this magnetic field intensity is the amperes per meter, and it is a vector quantity. It depends on both the magnitude as well as the direction. How to formulate the magnetic field from various current elements, from infinitesimal current elements. So this magnetic field intensity is directly proportional to the current element. Current element is every segment of the current carrying wire which contributes to the magnetic field, and inversely proportional to the square of the distance. It is a vector cross product. It is perpendicular to the current as well as the displacement vector. Then what are all the different configurations from which the magnetic field intensity can be calculated using the Biot-Savart law? First one is a long straight wire. So by using the Biot-Savart law, we can determine the magnetic field intensity at the point due to this long straight wire. Second one is a circular loop. At the center of a circular loop, what is the magnetic field intensity that is being created can be determined. Third one is a solenoid. So we can analyze the magnetic field intensity in solenoid using this Biot-Savart law. So for all these three configurations, we can calculate the magnetic field intensity using the Biot-Savart law. And next one is the Biot-Savart law. According to Biot-Savart law, the magnetic field intensity is directly proportional to the product of current and the dl, which is nothing but it is a current element, and inversely proportional to the square of the distances. So through this Biot-Savart law, we can calculate the magnetic field for various conductor shapes. It is used in the electrical devices. It is being used in the electrical devices design and the magnetic field analysis, and where these magnetic fields are being encountered. MRI uses this magnetic field for detailed imaging, medical imaging, and maglev train uses this magnetic field, utilize a magnetic field for high speed travel, and electric motors generally relies on the magnetic field, and for data storage the magnetic field are efficiently used. And next one is an analogous between the electric and magnetic field. In case of electric field, static charge is a major source, and for magnetic field, the steady current is a major source. The field in case of the electrostatic field are END, electric field intensity, and electric flux density, whereas in case of magnetic field, it is magnetic field intensity and magnetic flux density. The factor for this electric field is a epsilon, permittivity. For magnetic field, it is a permeability. And Maxwell equation that is being related to this electric field is a del dot D is equal to rho V and del cross E is equal to 0, where D is a electric flux density, E is a electric field intensity, rho V is a volume charge density. For magnetic field intensity, it is del dot B is equal to 0 and del cross H is equal to 0 equal to J. J is the electric current density, B is a magnetic flux density, H is a magnetic field intensity. Potential in case of this electric field is a electric scalar potential, E is equal to minus del V. V is a potential difference. Whereas in case of this magnetic field, it is a magnetic vector potential, which is B is equal to del cross A. A is a vector magnetic potential and V is a electric potential, electric scalar potential. Energy density in case of this electric field is equal to 1 by 2 epsilon E square, whereas in case of magnetic field, it is 1 by 2 mu H square. So far we have discussed about what is a magnetic field intensity and what is a Biot-Savart law, what are the different configurations in which a magnetic field intensity can be determined, and finally the applications of this magnetic field, and finally about the difference between or comparison between this magnetostatic and electrostatic fields. Thank you.